The standard form for an equation of a circle is x minus h squared plus y minus k squared equals r squared. The center is hk, the radius is r. So this should be pretty easy for us. Number 1, find the equation of the circle in standard form whose center is at the point 2, 5 and passes through the point negative 1, 3. So if this is the center, that's hk, right? But this is point xy. And I want you to think about this. This is not the only way to do it, but I thought of this the other day, and I was like, in the past what I did is I did the distance formula to find the radius. And I'm like, you don't have to do that, actually. Do you see I have an x in the h? So that's negative 1 minus 2 squared plus 3 minus 5 squared equals r squared. Yeah. Negative 3 squared is 9. Negative 2 squared is 4. Remember a negative squared? And guess what? It does not ask me to find r, does it? But it asked me to come up with the equation, and it equals r squared. So why on earth would we waste our time doing the square root and then squaring it? That's like goofy. So here's our equation. This is x minus 2 squared plus y minus 5 squared equals 13. Okay, I already have the r squared. Number 2, find the equation of the circle whose diameter has these endpoints. And I'm just going to make them up, okay? This is negative 5, 4. Of course, it's not actual, okay? This is not where it really is, but we're going to just make a diagram here. So if these are the endpoints, how would you figure out where the center is? We have a tool in our math tool belt for this. Midpoint, okay? This is the midpoint. The midpoint would be the center. And the midpoint formula, hopefully you haven't forgotten this. You'll find that on the final exam review packet.
I have a question.
Yeah.
Will there be like a sheet?
Let me think about that. I was thinking about letting you guys bring in a sheet with formulas on it, like you write them.
Okay.
Because I wasn't going to. The other thing is 80 problems, that's a lot. Okay, that is a lot. But if you would do 4 or 5 a day, 5 days a week, you'll have it done. Okay, do 4 or 5 a day. Just kind of, make it part of your daily. Brush your teeth and do 4 pre-cut problems. That'll do it for you. I know that's goofy, but it would certainly work. Brush your teeth, 4 pre-cut problems. Okay, so let's find our center. You're going to take 1 plus negative 5 over 2. And, negative 4 plus 4 over 2. That's negative 4 over 2 is negative 2, comma, 0. That's your center. Now we need the radius. You can find the radius one of 2 ways. You can either do the distance formula and find the distance from the center to an endpoint, or why not do what we did up here? Either way is fine. So I'm going to use the x minus h squared plus y minus k squared equals r squared. It does not matter which point you choose. I can pick this one, but with my center. Okay, I'm picking this one with my center. I could have chosen this one with my center. So this is negative 5 minus negative 2 would be plus 2. 4 minus 0 squared. Negative 3 squared is 9. 4 squared is 16. Again, I don't need r. I need r squared. So my equation then would be x plus 2 squared plus y squared equals 25. Now, if I need the radius, I can certainly do the square root of 25. So stop and think about this. If I have the endpoints of a diameter on the circle, find the midpoint, and that's the center. You can find the radius at least one of two ways. Either do your distance formula, but I think that's a little bit harder to do, or use your circle equation, pick one point of your endpoint with the center and find r squared, okay? All right, number 3, this ties into the chart we'll be filling in, and I'm going to fill that. I'm going to see you guys Monday, Wednesday, Friday, not Tuesday, Thursday. So Monday I'm going to do the hyperbola. Wednesday we'll fill in the chart. Okay. So if you want to find the center and radius of a circle, and it's in the general form, here's what you're going to do. You're going to separate the x squared and x, the y squared and y, and move the constant to the other side.
And all the oranges, make sure you turn your home.
Now, we're going to complete the square. Because the general form of a circle looks like this. So we're going to complete the square here. So this is x squared plus 12x plus blank, plus y squared minus 16y plus blank. And on the right side, I'm going to have plus blank plus blank. And Anna Laura, what I put on your desk was the final exam review packet. It's due Wednesday, May 18th. And it's 80 points. It's a lot. Now, if there would happen to have been a number in front, you would have needed to have factored that out first, okay? So I take half of 12, which is 6, and I square it. So I add 36. I take half of negative 16, which is negative 8, and square it. That's 64. So this is x plus 6 squared plus y minus 8 squared equals 110. Now I can identify the center and the radius. So what is my center here? Negative 6, 8. And what's my radius? It's not 110.
The radius is going to be 110 squared.
The square root. The square root, because that's equal to r squared. All right, so in a nutshell, that's everything you need to know about a circle. Pretty easy. Pretty easy peasy. All right, here is an ellipse. And there's a lot here you need to write down. So go ahead and start writing. While you're writing, I have another handout for you that I don't have. If I have time today, we'll talk about it. If not, it's going to push to Wednesday. But I want you to put it away if you have time to read it on your own. This is why conics? Why on earth would we bother to study conics? And I was thinking on my way to school today, I was like, students think math is dumb. And, of course, I love math, and I think it's so much fun, and I get discouraged sometimes when I hear students complain so badly about math. And what I was thinking about is, if we keep writing while I yak, but I thought, if we didn't have math, I'm like, I don't think students really realize this. If we didn't have math, we wouldn't have cell phones, we wouldn't have TVs, we wouldn't have computers, we wouldn't have washer dryers, you wouldn't have grocery stores, we wouldn't have banks, we wouldn't have compounding of our money. There are so many things. Air conditioning, we wouldn't have air conditioning without math. So there's so watches, you wouldn't have watches. I wouldn't have my Fitbit. I love my Fitbit. There's so many things that we have and we use and we take for granted. And I realize that some of you are not going into engineering where you're problem solving to do some of that. But we certainly should have an appreciation for the people who are doing it. And some of you will go on to be engineers. And so we need you. So we wouldn't have medication. Do you understand that? In medicine, you wouldn't have x-ray machines, MRI machines. You know, we wouldn't have hospitals without math. So there's a lot to be thankful for, and, you know, maybe just have a little bit more appreciation that, yeah, you may not end up doing that particular math thing later, but it isn't a waste of time. The thought process, the logical thinking, the critical thinking skills are fantastic for no matter what job you go into. You will be thinking, hopefully, and using your brains. So math will do that for you. But I just thought, man, there is really a lot to be appreciative for. And then as I had used this packet when I taught at my previous school, I had to go find it though on the internet, and it's hilarious because I'll just read maybe the first group of parentheses while I'm waiting for you to finish. It says, mathematicians have a habit of studying just for the fun of it things that seem utterly useless. Then centuries later, their studies turn out to have enormous scientific value. There is no better example of this than the work done by the ancient Greeks on the curves known as the conics, the ellipse, the parabola, and the hyperbola. They were first studied by one of Plato's pupils. No important scientific applications were found for them until the 17th century, when Kepler discovered that planets move in ellipses, and Galileo proved that projectiles travel in parabola shapes. Apollonius of Perga, a 3rd century BC Greek geometer, wrote the greatest treatise on the curves. His work, Conics, was the first to show how all three curves, along with the circle, could be obtained by slicing the same right circular cone at continuously varying angles. So, you know, you don't want to say, gosh, that's so useless, you shouldn't bother. And that was true with logarithms. The logarithms, John Napier is the person who is credited with discovering logarithms. It was, I think, 300 years before they figured out how you could use them. And so you don't want to say, oh, don't bother studying them. Yeah, it might end up not being in your lifetime, but having that groundbreaking information, then somebody else comes along. You know, and figures it out.
Junior class to report to PhD. Front center section.
Are you here? Okay, make sure you watch the video and you have the doohickey, okay? The homework. It says ellipse circle homework. It's in your packet of stuff, okay? But watch the video all over. Okay? Where is it? Because I'm still marching on.
What did I get? Literally like
What's that?
this one? Oh, it's more than half. It's
more than half. Yeah. Yeah, that one. All right. The most important. All right, it's all right. It says the set of all points in a plane whose sum of the distances from two distinct points, they're called the foci. They have two focuses. Okay, and the plural of focus is foci. The foci are the two distinct points inside the ellipse. The vertices are the endpoints. You have what's called the major axis and a minor axis. And so what I want us to do is I'm going to draw a picture here. And an ellipse the foci. This is called the major axis is the longer one. And then this one is the minor axis, but it can be flipped, okay? It can actually be flipped. The center is where the two axes are intersecting because they're not always at the origin, okay? It's not always at the origin.
Is this happening? Yeah, I haven't seen it.
Okay, so the standard equation, do you guys see that there? So you have a major axis, and A is always the larger number, okay? And A indicates what kind, so A is always larger. A is always larger than B, and it indicates the major axis. So if you think about X, if you think along the x-axis, that's left, right, that's horizontal. And Y is up, down, it's vertical. And another piece of information, I don't see it up here. Oops, I was supposed to write this down. C squared equals A squared minus B squared. And once we do a few of these, it's actually just as easy as the parabola that we did yesterday, okay? So don't be freaked out. It's really not that bad. So in number 1, it said find the standard form of the equation of an ellipse whose foci are 0, 0, and 4, 0, and whose major axis has a length of 8. So here's the deal. You do want to draw a graph. And there's two foci. The foci lie on the major axis, okay? So that means my center is halfway between. So my center is at 2, 0. And then it says that the major axis has a length of 8. So from the center, it's going to go 4 to the right and 4 to the left. So I have vertices at 1, 2, 3, 4, 5, 6, 0, and -2, 0. I have vertices. The distance, okay, C equals the distance from the center to a foci. So when we say C squared equals A squared minus B squared, A and B are in the equation, but the C value, that's not the center, okay? But the C value is the distance from the center to the focus. So what is C here then? If C is the length from the center to the focus? 2. And then I'm going to use this one. The major axis is horizontal. And the length of the major axis is equal to twice the A value. Okay, the major axis is twice the A value. So if my major axis is 8, what's A?
I have no idea what's going on.
It says in the problem, the major axis is 8. And I'm telling you that the major axis equals 2 times A. A is 4. Now you're going to use C squared equals A squared minus B squared. And the thing is, like, you don't have to memorize any of these formulas. We'll have them all written on the chart, okay? So this is 2 squared equals 4 squared minus B squared. So let's solve that. And I only need B squared. I don't need to find B. So this is 4 equals 16 minus B squared. Do you notice we can add B squared and subtract 4? So now I can write the equation for my ellipse. This is x minus 2 squared over 16 plus y squared over 12 equals 1. Now let's finish the ellipse. Like, we're not done with it. If b squared is 12, on your calculators, b is the square root of 12, right? Can somebody grab their calculator and do the square root of 12? If I can do it. It's like 3.5, right? Yeah.
How do you know which standard equation to use for the problem?
Okay, the focus is on the major axis. And so they told us that the foci were at 0, 0, and 4, 0. So they're lying together on a horizontal line. If they had gone this way, we would have used that one.
Okay.
Okay, the foci or the vertices tell us which one is major.
Okay.
Okay, so now from C, I need to go up 3.5. So count up 3.5. So that's at what? So I have, they're called co-vertices. We're going to call them co-V. So it's 2, 3.5. And then I would go down 3.5. So that's 2, negative 3.5. And then watch this. Here's my ellipse. And it looks awfully close to a circle, and it should. Because here I went 4, and here I went 3.5. That's really close to a circle. All right, so let's do another one. In number 2, find the standard form of the equation of the ellipse whose vertices are at 0, 5, 0, negative 5, and whose foci are at 0, 3, 0, negative 3. So let's draw a picture. So I have vertices here. Can you tell right away, since the vertices are vertical, this is going to be the second one, okay? Now, the major axis is equal to 2a, and the major axis is the length from vertex to vertex. So how long is the major axis? They didn't come out and tell us, but we have enough information. What is the length of the major axis? 10, right? So it's 10. So now I have A is 5. Okay, the major axis is the length from vertex to vertex. Now the foci are at 0, 3, 0, negative 3. Now the foci tells me the value of C. It's the distance from the center to the foci. So I actually have my center as well. Can you tell the center is halfway between the foci or halfway between the vertices? So can you tell that the center is on this one at 0, 0? So then what is C? C is the distance from the center to the foci. So that's 3 units. Okay? The C value, we wrote it here. C is the distance from the center to one of your foci. Now we can find B by using C squared equals A squared minus B squared. So that's 3 squared equals 5 squared minus B squared. So what's B? Or B squared? B squared is 16, so B is 4. So what that means, I have co-vertices that are 4 units from the center. So I have co-vertices at 4, 0, and negative 4, 0. So now I've got my ellipse. And then I can write my equation. This major axis is vertical, so it's x minus h squared over b squared plus y minus k squared over a squared equals 1. A is always the bigger number, so if you were given the equation, you could tell which is the major axis, by looking underneath the x and the y's to see. So this is x squared over 16 plus y squared over 25 equals 1. All right, questions? Yeah.
How do you find the foci?
Two ways. One, if you know where the center is, you have c squared equals a squared minus b squared. So like in both 1 and 2, I was given the foci, like I had it. You would have to know the vertices and co-vertices then to find it. Okay? Yeah.
What did you plug in for H and K?
The center is 0, 0. So the h is 0 and the k is 0, so that's why I have x squared and y squared with no other number. Okay? All right. Let's look at example 3. It says, write the equation of the ellipse in standard form. So what we're going to do is you're going to group the x's, you're going to group the y's, and you're going to move the constant to the other side. So this is just like what we did with the circle. So then what I'm going to do is we're going to need to complete the square. The problem is on the y squared, there's a number in front. So what I want you to do is I want you to pause a moment and really look at what I've done. I factored out the 5, and that left me with y squared minus 14y. Do you guys see that? That I factored out the 5. All right, then we're going to complete the square. I take half of 4, which is 2, and square it. So I add 4. But you have to add it to both sides of the equation. Now, this next part's tricky. I take half of 14, which is 7, and square it. Inside the parenthesis, I'm adding 49, but on the right side, I'm not going to add 49. What have I actually added on this left side? It isn't 49. 5 times 49, which is, I think, 245. Try it. Yep. So now, this is x plus 4 squared plus 5 times y minus 7 squared equals 40. Now the thing is, if you look back to the front side, your standard equation, it always equals 1. Did you notice that in both of them? They both equal 1. So you're always going to divide by whatever's on the right side to make it over, or make it 1. So this is now x plus 4 squared over 40. Now 5 and 40 reduce, don't they? So this is y minus 7 squared over 8 equals 1. Now pause a moment. Which number is bigger? The value under the x or the value under the y? The x. So that means the major axis is horizontal, okay? That's cool. So you can tell, just looking at the equation, it's longer this way. The square root of 40 is where your vertices will go. All right, let's try it again. Number 4 is nothing new. We're going to group together the x's and then the y's and move the constant to the other side. Now I'm going to get ready to factor by grouping. I'm sorry, completing the square, sorry. But in order to complete the square, you have to factor out that x squared's coefficient. Not a GCF, but just what's in front of x squared. So this is 9 times the quantity, x squared minus 6x. We're going to finish this in a moment. I pull out the 4 and get y squared plus 10y. All right, so here we go. Take half of 6, which is 3, and square it. But I'm going to add 81 because it's 9 times the 9. Take half of 10, which is 5, and square it. But I add 100. All right, then tidying that up, I get 9 times the quantity, x minus 3 squared, plus 4 times the quantity, y plus 5 squared, equals 144. The general form for an ellipse has to equal 1. So I'm going to go through and divide by 144. Now on this one, it says find the center, the vertices, and the foci. We were not asked to do this in 3, so we're going up a notch. Well, my center is 3, negative 5. Okay, you can just read off the center. A is always the bigger number. It goes like over b squared and a squared. So what's A here?
36.
No, A is not 36.
Oh, wait, that's b squared 6.
It's 6. Then B would be 4. I can find C by doing C squared equals A squared minus B squared. So 36 minus 16, C squared is 20. The square root of 20 is about 4.5. So we're going to need this in a moment, okay? So let's stop and think about this. Here's my center. Like, I'm visual. I've got to kind of plot these out. Is the major axis horizontal or vertical?
Vertical.
It's vertical because it's under the y. So the major axis is vertical. So that means my vertices are going to go up and down. And they're going to go up and down by A. So I need to literally count up 6. So I have a vertex at 3, 1. And then if I were to count down 6, do you see that's 3, negative 11? You see what I'm doing? From the center, if it's a vertical major axis, you go up and down A units. Now, to get the foci, you're going to go up and down C units. So then my foci would be 3, and it would be negative 5 plus 4.5, so that's negative 0.5. And 3, what? Negative 9.5. I can also find my co-vertices. The co-vertices are going to go B units right and left. So if I take 3, negative 5, and I move to the right 4, that's 7, negative 5. And if I move left 4, that's negative 1, negative 5. Okay? And then there's one last thing, if you have time to jot it down. I'm not going to give you any problems on it, but there is something called eccentricity. It measures the ovalness of an ellipse by E equals C over A. And the closer that is to 1, the closer it is to a circle. That's all that means. I will scan out the the solutions to the homework, so that might help a little bit. Because I know I went rather quickly